This is All Things Ansys, a podcast for the technical support staff at PADT. Episode 86, a review of what is new for thermal integrity with a look at Ansys news and events. Greetings, I'm Eric Miller, one of the owners of PADT and your host on these podcasts. Well, last week was actually a vacation for me, and I've had such a great time that I forgot to record this part of the podcast. So apologies to that. Basically, this is going out a day late. I meant to record this from the forests of northern Arizona. I was up in Flagstaff, but ended up spending my time hiking about and visiting the Grand Canyon instead of really doing this, which I'll admit, I'll have to confess is not a bad thing. I don't feel too guilty. A small advertising for Arizona. It really is a beautiful state. If you're not someone who lives here, I recommend you find some time to visit. Sedona and the Grand Canyon are must places to run around and hike and see nature, but there's so much more here. But this is not the All Things Arizona podcast. It's the All Things Ansys podcast, and we need to get on to our Ansys things. Today, we all saw the very first aircraft fly on another planet. It's April 19th. NASA's helicopter Ingenuity took off, buzzed around, and landed safely. And as you can imagine, not an easy thing considering the atmospheric density is 1% of the Earth's. It's 95% carbon dioxide instead of nitrogen and oxygen. Oh, and the temp is minus 60 C during the day. One advantage, though, is that it's 1/3 the gravity. How did they design the blades and figure out what RPM and such were needed to get a certain thrust? Well, they used Ansys Fluid. According to a research paper put out by NASA, they used Fluid to calculate the lift, drag, and something called the pitch moment as a function of the angle of attack and rotational velocity of the blades. These results were put into a table and used in the control system for the aircraft. You can learn more about it by going to the Ansys blog. It's blog.ansys.com and searching for the entry on the helicopter. It's pretty exciting stuff, and it's so cool to see the tool that we use every day used for that product. And I'm thinking that maybe some other areas use Ansys as well. Hopefully, over time, we'll find out more stuff. So let's move on to our interview. Another key part of designing a system like that helicopter is thermal integrity. Stuff gets hot. I don't know if NASA used IcePack or some other tool, but they certainly could have used IcePack to simulate their electronics. And a lot of things are new in this release of the IcePack suite of products. So let's have a listen to Josh sharing what he learned about what we call thermal integrity simulation at Ansys 2021 R1.
I want to welcome Josh Stout here again to talk about some cool stuff with me. And I am up here in Flagstaff. I think I was just telling you that, Josh. So if the audio goes in or out, I'm going to blame it on the timeshare Wi-Fi. So, those maintenance fees for anybody that has timeshares. How are you doing today, sir?
I'm doing just fine. Not quite Flagstaff level good, but as good as can be.
For those of you who are listening who aren't from Arizona, Flagstaff is up in the mountains, so it's a good 20 to 30 degrees cooler up here. So it's now's the time of year to do that. So today we're going to talk about thermal integrity, right? So which is mostly the IcePack products, correct?
Yes. So of course, when they say thermal integrity, they're talking about things that are related to thermal solutions, and that's mostly going to be oriented towards electronics. So ultimately what that ends up meaning is IcePack. Yes. Good.
Well, we certainly like IcePack, and it's come a long way in the last couple of years. So let's get started with what your favorite enhancement is in this new release.
Ooh, that's actually a tough one for this release because there are quite a few pretty high profile additions here. I think maybe the most important thing is actually a little bit ironic considering we just talked about thermal integrity, but it is the addition to the mechanical solver to electronics desktop IcePack. So while this is the mechanical solver, it is still a thermal solver. It's not actually solving stresses, but it lets us do things like modal frequencies, I guess, are on the mechanical side, but on the thermal side, it lets us do more thorough, more robust coupling with the electronics tools, since we can use the same meshes and we have a little bit more flexibility there than we used to.
Good. So you can do a little bit more sophisticated thermal analysis using that tool rather than Fluent for your solid parts, right? That's kind of what,
yes. Yeah, of course, it is going to be for the solid parts since it's just mechanical, not Fluent. Yep.
Good. Well, I'd love to see that kind of integration happening, just more capability. What else has got you excited?
There is a feature that has been in the works for probably the last year or so that now finally has an interface associated with it, and that is the thermostat enhancement. It's the dynamic thermal management.
Ooh, tell me about that.
Yeah, it's still flagged as a beta feature, but
Okay.
it has, like I said, it has an interface associated with it, so you can actually use it now without doing custom scripting and things. But basically what that lets you do is control the power output of some power source based on an arbitrary temperature.
Oh, nice.
So this is like if you have a CPU on a motherboard and you're throttling that CPU based on the air temperature above it. That was believe it or not, that was a feature that we couldn't do in IcePack before. But
okay.
Now we can with this thermostat. So we can model things more accurately. We can include some control algorithms for dynamic runs and things like that.
That is really useful. And I think more and more products, right, have temperature dependent power output, right? So they're kind of self-monitoring. Yeah,
especially all these high performance electronics. They're super high power levels and they get hot, so they have to throttle.
Yeah, exactly. Well, that's very cool. Any like user interface enhancements this time around to just make things run easier or smoother?
There are a number of things. I would say probably my pick out of the user interface type things is that they have separated the flow and the thermal monitors. So in the past, if you defined a flow and a thermal monitor on the face of an object, it would plot those in the same plot. Of course, there would be two different scales, so you could figure out which was which if you needed to, but it was just kind of awkward and cluttered, and you'd have to turn one off or the other off just to kind of know what's going on. Now they actually have separate tabs for those two different kinds of monitors, so it's much easier to use. Yep.
Good. That is one of those little things that probably makes a big difference, right? Yeah.
Yep, for sure.
Good. Any other changes that users should know about in that these tools?
I would just generally say that one of the larger updates this time around is the addition of a bunch of different toolkits. So these are all, I would say they're mostly quality of life things. I mean, they're technically things you could do before that just required a little bit more manual work. But having these toolkits, I mean, it's related to what you're asking about the user interface improvements for sure. But being able to, for instance, include a heat exchanger network, just using this toolkit where you can specify, what plane is it on, what sides are you modeling on it, how large is it, what kind of heat exchanger, so is it a flow through or is it looped? All of these things, just having them present within a single user interface is really, really nice. And I think those kinds of things were maybe complicated enough before that people may have been hesitant to even try and model them. But now that we have kind of a starting point to build on, we can do a lot more with it.
So very much quicker to get those capabilities in your model than kind of having to do it the brute force way. So that is a big difference. Yeah. And as we get more and more complicated assemblies, my son's summer job in between colleges, he works at one of those you break it, we fix it places. And one of the things he's finding in these newer devices is how much stuff is packed into such a small space. And I thought, well, you can thank IcePack to some extent for that, because these companies use IcePack. These major electronics companies all use IcePack in order to keep that stuff cool, or figure out how to keep all that packed in stuff cool. Because it does make it difficult to repair, but it does make for a compact device. So he wasn't pleased with that as being the thing. He wants a big open box that's got lots of room and a big printed circuit board with very few components on it. Anything else out there with noting?
I'd say, maybe the last thing I'd note about the electronics desktop in particular is that they're also expanding on these solar radiation capabilities.
Oh, okay.
So, I'll admit that was kind of one of my complaints about one of the last couple of releases when they first added this calculator for solar radiation.
Mm-hmm.
Really, all it did was tell you how much solar radiation would be present at a certain latitude and longitude and time of day. It didn't actually apply that to your model.
Oh, yeah, I can Google that.
Yeah, exactly. Well, now we can take it to the next step where you actually apply it to your model.
Okay.
So, I expect this capability will continue to grow as far as how advanced it is. I think Fluent is still a bit ahead of IcePack here, which makes sense.
Okay.
But there's certainly more usability here. I would say borderline it wasn't usable before, but now it is. So that's always nice.
What's a good use case for that? Like I leave my laptop sitting outside and I want to know how much heat gets into it from the sun.
Well, that could certainly be an extreme case. You could always couple that with something like the dynamic thermal management, so you could see, how much more throttling is required if you're out in the sun versus not.
Mm-hmm.
I would say, just off the top of my head, the biggest use case for this would be solar panels.
Oh,
of course, there are a lot of electronics in those, and we
yeah.
expect them to be sitting in the sun. So being able to more accurately model those loads is important.
Gotcha. Or even like now my brain is, I'm thinking consumer electronics, but now that switched my brain over to say a 5G switch box, right?
Sure.
All that hardware that you've got in that that little box that controls the 5G antenna, that's going to see different sun during the day.
Yeah, or
okay,
maybe
that makes sense.
Maybe we're modeling a 5G antenna that's just sitting outside in the sun too. Yep.
Right. Okay. Yeah. Sometimes I think too much consumer electronics, and there's a whole other set of industrial and even defense applications probably as well.
Yep.
Good. Well, always good to catch up on this. Is there a webinar coming up, or have you done the webinar on this one so far?
We did have a webinar at the end of last week, I believe it was.
Okay.
So the recording should hopefully be available. I believe all the slides are there as well if people like to look into it a bit more depth.
Yep. You definitely get more information there and see the pictures of it, and we just continue to see more and more functionality in IcePack. And if you're doing electronics assemblies and not using IcePack, you don't have very many excuses anymore. So do reach out to your Ansys support provider and have them show you what you're missing, especially with the new interface. The electronics desktop interface is just so much easier to use and powerful, and lots of cool stuff going on. Well, Josh, thank you very much for your time. I always learn something new and different, and we'll look to hearing about the next upgrades or new products next time we chat.
Yep, sounds great. Thanks, Eric.
Thank you.
I want to thank Josh for that. Always informative. If you want to learn more, you can go to brighttalk.com and search for PADT to find all of our webinars, including the one on this topic, or reach out to your Ansys support provider. And now it's time for our fun commercial. Did you know that small or medium-sized companies located in the southwestern U.S., Texas to California, can purchase your Ansys tools from PADT? And even better, they can get their first-line technical support from the experts you hear on this podcast. PADT is a certified elite Ansys channel partner in Arizona, California, Colorado, Idaho, Kansas, New Mexico, Nevada, Texas, and Utah. If you or someone you know are looking for a source for your Ansys tools and support, reach out to info@padtinc.com and we will investigate how we can work together. If you're listening to this podcast, you're probably already working with Ansys directly or PADT, hopefully, or maybe another channel partner. So that's fine. No need to change. But other engineers, may be looking for an Ansys solution partner. Or maybe you just changed jobs and you're looking for who you're going to buy your Ansys from. So send them our way or come our way yourself, and we will take good care of them. Let's take a look at the Ansys stock. It was a bad day, Monday, April 19th on the market, and Ansys got hit just like everybody else. It's sitting at 364.47 right now, which is better than the 293 it hit in the early March timeframe, but not as good as the all-time high that it had back in February of this year at 413. or it had a little mini peak at 374 last week. The price puts it about where it was at the beginning of the year, so about 0% increase year to date. But the S&P 500 is up 10.84%. So it's the rare situation where the Ansys stock is actually underperforming the S&P 500. So we'll see how that changes. The earnings call for the first quarter of 2021 will be on May 6th, and we'll learn a lot then. There is no Ansys news to share with you because they always go quiet before their earnings report. Our big news here at PADT is that we are now a distribution partner for metal 3D printing leader EOS. They are the dominant player in laser powder bed fusion, or also called direct metal laser sintering. We now represent their metal 3D printers in Arizona, California, Colorado, Idaho, New Mexico, Nevada, Texas, and Utah. So if you or anyone you know is looking to add a metal printer, reach out to PADT. We've been using their printers for quite some time. We're a big fan of them, and they asked us to be a reseller for the same reason other companies ask us, usually because of our technical knowledge and depth. So that's a good reason to reach out to us if you're looking at a metal 3D printer. Let's take a look at the Ansys blog. I already mentioned the post about the Mars helicopter, but I'll pick 3 more because there's some good ones in there. My first pick is an article by the Ansys CTO on how artificial intelligence and machine learning are changing simulation. This is a must read for everybody because, like it or not, AI and ML is coming to the world of simulation. So better understand where it's going to fit and what it's going to do to make life better for us. Number 2 is building better batteries. Characterize battery parameters for simulation. It's an article on how you can use testing to develop an accurate simulation model that you can then use to investigate your system's performance. So important stuff. It's really important stuff as we rush down this road of electrification. Everybody's looking at batteries and how they fit into their system. And this is a great way to get the data you need to put that in your simulation model. And my third one, I really like hydrogen as a power source, and I have spent a lot of time in my career looking at combustors. So this next post talks about both of those. It's about modeling hydrogen combustion in Fluent. It's called Realize the Sustainable Promise of Hydrogen Combustion. If for no other reason, check it out for the really cool animation of flow in the combustor. It's a very technical post that gets into a lot of parameters that drive the performance, so I recommend that for anybody interested in combustion or just cool simulation. We didn't have a chance to put anything in the Ansys or PADT blog since we last talked. So let's move on to events. Simulation World is tomorrow. So hopefully you've all registered. Hopefully you're listening to this in the middle of or after listening in. It's the 20th and 21st. You can still register. And even if you register after the event, that gives you access to all the recordings. Everything's going to get recorded and put on the internet. So you won't miss anything, even if you're not there live. Although live is fun because you get to comment and talk to other people. If you do go, please stop by the PADT booth and say hi. If no one is there, leave us a note and let us know you're a listener. We've got an upcoming webinar, Mechanical Analysis Update in Ansys 2021 R1. That's going to be on the 21st, which I think is Wednesday at 11 a.m. Pacific and Arizona Standard Time. And then the only other 2 events that we've got this month, one is a golf tournament. We actually, the PADT's VP of Engineering, Tyler, and one of our salespeople for Ansys, so you may have him as your salesperson, Dan Christensen, are going to be on a team with 2 of our customers from Freefall Aerospace, and we hope to do well this year. So that's down in Tucson at the Arizona National Golf Club. So if you're down in Tucson or like to golf, there may still be some space left for that. That's going to be on Friday the 23rd. I'll let you know how we did. And then the last event of the month is on the 28th of April. And it's actually called Experience Stratasys. It's really a look at what's new in the world of Stratasys. There's a lot of new products coming out on the 28th, actually. And they're going to be announcing them as part of this event at 9 o'clock Central Time, which is going to be, 7 o'clock Phoenix time. So check the news for that, even if you don't check out the event. There's some pretty cool products coming out from Stratasys next week. And that is pretty much it for events and for news. So we're done. I want to thank everybody for joining me here in my backyard in Phoenix. The airplanes and loud cars going by. I hope that's not too much of a distraction. Don't forget to subscribe to the podcast at www.padtinc.com/opt-in, and do spread the word. Subscribe to the podcast itself from the whatever service you use to get your podcasts. And as always, do not hesitate to reach out. And thank you very much for listening. Thank you for joining us for the All Things Ansys podcast, episode 86. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.